In this video, I'll be explaining the concept of multiplicity with the polynomial graphs. But if you just want to make sure you're good to go with this question here in multiple choice format with the description of the graph here. So pause the video and then choose your answer. Let's see what you think. And here we go. So notice here that the first option, the values of f of x are positive over the interval, the x values from 0 to 1. But notice here from 0 to 1, my values are not positive, right? Because it's below the x-axis. These values are negative. So that statement does not describe. So now let's go to B. B says they are increasing, the values are increasing over the interval. So again, x values, -1 to 0. But now notice, read the graph left to right. Our graph is not increasing, our graph is decreasing. So B is not the answer. And then go to C. The function is odd. Well, let's see here. Yep. So this is odd, right? Because they're going opposite directions. For this to be even, it would have to look something like this here, where we're going the same direction. So like this graph represents a positive even. This graph represents a negative even, right? Because the arrows are going both directions and going in the negative direction. So here we do have an odd function. So then it says that with a positive leading coefficient. But notice, read the graph left to right. What direction are we ultimately headed? We are officially going negative. We're going down. So that's why the answer was not C, why the answer was B. So notice here, as x values approach infinity, so as we're going to the right towards positive infinity, my values are approaching negative infinity. So like here, as x values are approaching negative infinity, then the values are approaching positive infinity. So now here, again, notice, right, this is going back to our factored form. Notice here, x plus 5 times x plus 1 times x minus 3. Notice what are the zeros of your function. -5, -1, and +3. So notice here, -5, -1, and +3. So that is our zeros. So if I were not to look at the graph, but I'm given the g of x here is x plus 5 times x plus 1 times x minus 2, then what would my x-intercepts or zeros be in this case? -5, -1, and +2, which matches. So then here, h of x tells us x plus 4 times x plus 1 times x minus 2. So that means my zeros or x-intercepts would be -4, -1, and +2, which matches our function here. Now, keep in mind, this is different though when we're talking about what about if there's a factor that occurs more than once, because all of these only occur once because there's an exponent of 1. Notice there's an exponent of just 1 here. What if you have a factor that appears more than once? Then that means that root, the x-intercept, has what's called multiplicity. So that's this concept here, where we are still focusing on that value with our x minus r. So like here, if we have a slice, so like notice all of these were slices, right? Cutting through here. Then that means it has a multiplicity of just 1. So keep in mind, multiplicity is like the exponent of our factor here. So notice here, what factor has that multiplicity of just 1? Here at x is equal to 4. So that means in factored form, this would look like x minus 4. So that just has the multiplicity of 1 because it is a slice cut through. Now, if the root has an even multiplicity, then it's going to do where it touches the x-axis, or we could say it bounces off of the x-axis. So like here, for example, if it is even, notice here at -1, it goes up and touches, right? It bounces back down. So that means here at x is equal to -1. that root here has a multiplicity of 2. So that means we would write this as, in the equation format, x plus 1 to the second power, because again, focusing on a multiplicity of 2. So if a root has an odd multiplicity of 3 or more, then the graph is going to be bending or sliding. So like here, notice that x is equal to 2. We're like sliding through 2 here and then continuing on. We're not bouncing off of it. We're not slicing through it. We're just sliding. We're bending right through it, making that value 2 here. So here at x is equal to 2. That means we've got x minus 2, but this is to the third power. So here, let's identify the roots and multiplicity. So the roots here are -1 and +2. So x is equal to -1 and x is equal to +2. But then let's write it with the multiplicity, right? And let's write it in factored form. So this means this would be x plus 1. Now, what's the multiplicity at -1? Well, notice it just slices through it, and a slice is just an exponent of 1, multiplicity of 1. Then here, this would be x minus 2. But then notice this is not a slice. Notice how it's a bounce. So this is an exponent or multiplicity of 2. So now if I wanted to put this together, this would be x plus 1 times x minus 2 squared. So now let's keep going with our review. Is this an even or odd function? Well, it's an odd function, right? Notice how arrows are going opposite directions. So this is an odd function. Then the leading coefficient, is it positive or negative? Well, read it left to right. Notice how we're going down. So the leading coefficient is negative. Then here, the end behavior. As x approaches infinity, so as we're approaching infinity, what is our end approaching? Negative infinity. Then here, as x values are approaching negative infinity, what is our f of x approaching? Positive infinity. So here, we'll do the next one. Roots and multiplicity. So identify what are the roots? -3, -1, and 4. That's our roots. That's our x-intercepts. So here we're at x is equal to -3, x is equal to -1, and x is equal to 4. However, we have to consider multiplicity, right? So here we go. At -3, so x plus 3, what is our multiplicity? 2, because notice it's a bounce. Then here at -1, so x plus 1, what's our multiplicity? 1, because it just slices, cuts through, so we'll leave it. Then here, x is equal to 4, so x minus 4. What's our multiplicity? 3, because notice how here we've got our bend. So now here we go. The degree, is this even or odd? This is even now, right? Going both directions. Now, if you wanted to be specific, what is the degree? Well, the degree, right, is just add up your exponents. So the degree, notice, is not 5, right? Because remember, this has an exponent of 1. So the degree of our function is 6 from 2 plus 1 plus 3. So notice there's your even. Then is the leading coefficient positive or negative? It is positive. Notice how both are going up. So it's got a positive. And let's do end behavior. As x approaches infinity, so as we're going to the right, to positive infinity, what is our end approaching? F of x, positive infinity. So then here on the left, as x's are approaching negative infinity, right? As we're going to the left, what is our f of x approaching? Positive infinity as well. And if you want to put a positive, go for it. So now try this one on your own. And here we go. Roots and multiplicity. So here we're at x plus 4, x plus 2 and x minus 3, but then multiplicity. -4 is a slice, exponent of 1. Here, -2 is also a slice, exponent of 1, multiplicity of 1. But at 3 here, we have a bounce. It has an exponent of 2, so that's our multiplicity of 2. So is our degree even or odd? This degree is even, right? Notice how going both directions, same direction. And let's be more specific. What was the degree? The degree is 4 from 2 plus 1 plus 1. Then our leading coefficient is positive because ends are going positive direction here. Then our end behavior. As x's are approaching infinity, as we're going to the right, our end is f of x values are approaching infinity. Then here, as we're going to the left, as x values are approaching negative infinity, our f of x is approaching positive infinity.